Welcome back to the third part and the last part of the basics of physics. In today's video, I'm gonna teach you some formulas and some numericals associated with them. And our first formula is, so the first one is P is equal to F by A, where P is pressure, F is force, and A is area of contact. Now this is the pressure formula, and there are also some variations in this formula. So if the force acting on an object is perpendicular, then this force can become thrust. It's thrust. And there are also some other variations like P is equal to W by A if the weight is acting on it. And it can also become P, which is equal to W by mg if gravitational force is acting on the object. Now we're going to see the second formula. So here it is. F is equal to g m1 times m2 by r square, where F is equal to force, g is universal gravitation constant, m is mass 1 and mass 2, and r is the radius or distance square over here. Now this formula is used to find like the gravitational force between two objects, and this formula was invented by Isaac Newton, and this is the gravitational force formula. Now here's the third formula, but before that I can say that G is equal to 6.67 times 10 to the power of minus 11. This is very important since it's the value of G. And here's the third formula. And here it is, which is acceleration, which is equal to final velocity minus initial velocity by time. And you might be wondering, what is acceleration? Acceleration is just the rate of change of velocity. And here's velocity over here. Velocity is basically displacement covered by unit time is known as velocity. Now you might be thinking, then what is acceleration, which is equal to force by mass, which we discussed in the last video? Well, both are kind of similar formulas, but this is more valid. This is more of an accurate formula. So we just mostly use this formula. Now I'm going to show you some numericals which are associated with these three formulas. All right, here's the first one. The area of the bottom of a lunchbox is 0.25 meters and weight is 15 Newton. Calculate the pressure exerted by the box on the shelf. Now, since it says calculate the pressure over here, you can say that this is a pressure type of problem. And it says that the area of the bottom of a lunchbox is 0.25 meters and the weight, this is very important, the weight is 50 Newton. So as we know that P is equal to F by A, but since it's weight over here, we can say that it's P, which is equal to W by A. W is the weight. So weight is 50 Newton by 0.25 meters. 0.25 meters. Wait a minute. 0.25 meters. Now, if we do the calculation, we'll get a total of 200 Newton. Oh no, not 200 Newton. It's 200 Newton slash meter square. We can write it like this, or we can write it like this. PA. Since PA, Pascal, is the SI unit of pressure. And that's how you solve this sum. Let's move on to the second sum. Here's the second one. The gravitational force between the sun and the earth. Find it using the below data. So the mass of the sun is 1.99 into 10 to the power of 30 kgs. Mass of the earth is equal to 6 into 10 to the power of 24 kg. The universal gravitational constant, as we know, is 6.67 into 10 to the power minus 11. The distance or radius between them is 1.49 into 10 to the power of minus 11, sorry, minus 11. So this is a bit complicated question, and it's about gravitational force. Now we know F is equal to G m1 into m2 by r square, so I can easily solve this. So we'll take G as 6.67 into 10 to the power of minus 11 times 1.99 into 10 to the power of 30 times 6 into 10 to the power of 24 by 1.49 into 10 to the power of 11 10 to the power of 11. So now that we got our equation, you can now easily solve this. And after some simplifications, we can say that it is 79.64 into 10 to the power 43 by 2.22 into 10 to the power of 22, which is equal to 3.587 into 10 to the power of 22. Yes, it's a bit complicated sum, but if you practice enough, you can easily solve these type of questions. Now let's move to the third question. Here it is. A car accelerates from rest to a speed of 36 kilometers per hour in 20 seconds. Now, this problem is one of those acceleration type of problems, and this is a quite easy problems because we can say that acceleration is equal to initial velocity. No, actually, the final velocity minus the initial velocity by time. Now they gave that the final velocity is 36 kilometers per hour and the initial velocity is 0 since the car is at rest. Now we need to convert this into meters per second. So we can do 36 into 5 by 18, which is 10 meters per second. Since acceleration is always considered in meters per second. Now that we got our final velocity and initial velocity, we have the time, which is 20 seconds. So if we show this in a mathematical form, it is so it's 10 meters per second slash 20 seconds, which is equal to 0.5 seconds. Not seconds, meters per second. Meters per second. So that is it for the end of the basics of physics. I'll make a new video about the basics of chemistry in a couple of days. Thank you all so much for watching. Please subscribe, leave a like, leave a comment, and share this with your friends if you enjoyed it. And yeah, I'll see you guys in my next video. Goodbye.